International airport terminals in the 1970s were stressful liminal spaces. They were defined by chaotic intersections, perpetual waiting, and the latent anxiety of impending travel. The acoustic environment of these terminals was dominated by muzak. These sanitized instrumental pop covers were pumped through public address systems in a crude attempt to artificially stimulate the environment and enforce a sense of productivity and calm. In a complex transit space, this derivative, cheerful background music fails. It attempts to enforce an artificial emotional state that directly conflicts with the traveler's actual anxiety, transforming the audio into an irritating, manipulative distractor. In 1978, musician Brian Eno spent several hours delayed at Germany's Cologne-Bonn airport. He observed a stark dissonance between the terminal's sleek, multi-million-dollar architectural grandeur and the abrasive, uninspired soundscape. This friction catalyzed a novel approach to composition. Eno conceived Ambient One, music for airports, music designed to acknowledge doubt and uncertainty, accommodating multiple levels of listening attention without ever demanding focus. Eno designed this work as acoustic architecture, a functional tool built explicitly to mitigate the psychological friction of physical transit spaces. Today, the modern knowledge worker's digital ecosystem is psychologically identical to that 1970s airport terminal. It is an environment characterized by high stress, constant interruptions, and relentless mechanical pressure. This document outlines a modern technological catalyst, an unauthorized 6-hour time-stretched digital transformation of Eno's original album. It has accrued millions of views on platforms like YouTube, adopted by workers seeking sustained attention. As this section details, the modern user moves ambient music out of pure aesthetic appreciation. It enters the domain of cognitive ergonomics, deploying sound as a deliberate tool to shape human attention. The 6-hour track employs digital signal processing to create a mathematical mutation, hacking human neurobiology to enable deep focus. To understand how this digital mutation optimizes the modern brain for work, we have to reverse engineer the physical mechanics of Eno's 1978 original. Eno abandoned traditional linear musical narratives, verses and choruses, in favor of generative systems that act more like autonomous machines. He recorded incredibly brief, seconds-long improvisational fragments, using individual piano notes, overlapping female vocal choirs, and early synthesizers like the ARP 2600. These individual analog fragments were then physically spliced by hand into continuous tape loops of varying, mathematically incommensurate lengths. By playing these disparate tape loops simultaneously, the overlapping sounds create a continuously evolving, non-repeating sonic landscape. But this analog methodology has a neurological bottleneck: acoustic transients. These are the short, sharp attacks of a sound, the precise moment a hammer strikes a piano string. The human auditory cortex acts as a highly evolved predictive engine. It subconsciously seeks out and tracks these sharp transients to map the structure of the music. Because these transients still exist in Eno's 48-minute original, the brain eventually maps the repeating patterns. Even at low volumes, tracking these loops requires a continuous drain on working memory. The modern 6-hour transformation eliminates this drain, using a specific digital signal processing algorithm, granular synthesis. Granular synthesis deconstructs an audio file by mathematically slicing it into microscopic fragments, or grains, lasting only milliseconds. The software redistributes, scatters, and overlaps these grains. This artificially elongates the audio by hundreds of % without altering its original pitch. The success of this algorithm hinges on a strict mathematical trade-off: preserving time resolution, the rhythm, versus preserving frequency resolution, the pitch. To construct a seamless 6-hour environment, the algorithm forces a massive time resolution window. It prioritizes frequency at the absolute expense of time. The physical consequence is severe. All sharp acoustic transients are computationally smeared across time. The attack of the instrument is effectively erased. By obliterating the transients, the software leaves no attack, only an infinite decay. It strips away the music's narrative entirely, converting a discrete song into static acoustic architecture. This smeared waveform has an immediate neurological impact. Without sharp transients to track, the brain's predictive auditory engine is entirely disarmed. Human subjective time perception relies heavily on tracking external temporal landmarks and rhythmic pulses to measure the passage of seconds and minutes. This analysis of the listener's experience describes the resulting shift as temporal smoothing. Without auditory landmarks, the subjective perception of time passing is drastically softened. This temporal distortion allows a worker to exist in a continuous present tense. It eliminates the psychological friction and impatience that comes from clock watching during difficult cognitive labor. The audio functions as an atmospheric habitat, moving beyond the structure of a discrete, composed object. Stretched far beyond the brain's working memory capacity, the cognitive load required to process the sound drops to zero. The stage is perfectly set for deep focus. To see why this specific state is so effective, we have to move from subjective time distortion to the macro-level neurological networks that govern human focus. This is the default mode network, or DMN. It is a highly interconnected system responsible for mind-wandering, internal monologue, and rumination. Its functional opposite is the task-positive network, the dorsal attention network, forcibly activated during goal-directed tasks and acute concentration. These networks are strictly anti-correlated. They act like a seesaw. They cannot be highly active at the same time. Absolute silence allows the default mode network to flood the brain with distracting anxiety, while standard lyrical music triggers auditory alarms that constantly fracture the task-positive network. To achieve an unbroken flow state, a knowledge worker needs an external tool capable of simultaneously occupying the mind-wandering DMN without triggering the alarms that shatter the TPN. The 6-hour time-stretched ambient track modulates the brain's large-scale networks to balance internal mentation with task engagement. Through a process known as neuroaesthetic frequency tuning, the continuous, harmonic textures of the stretched audio provide just enough sensory data to gently pacify and satiate the default mode network. Because granular synthesis mathematically erased the sharp attacks, the audio completely bypasses the salience network. No auditory alarms are triggered. With the DMN securely anchored and the salience network disabled, the task-positive network is freed from internal and external interference. By utilizing low-frequency drones and rich harmonic overtones, the audio stimulates the production of alpha waves, neural oscillations associated with relaxed wakefulness. This entrainment provides a physiological baseline that prevents intense executive focus from turning into anxiety. Extreme digital signal processing completes Brian Eno's 1978 vision. It proves that the most profound and necessary acoustic architecture for the modern mind is that which is mathematically designed to be ignored.